Hello. Today we will be going over the triple pointed water cell. The triple pointed water cell is a sealed glass container that has a glass well that goes down its center. The water in this cell can exist in solid, liquid, and gaseous forms all at the same time. This is possible by finding the temperature and pressure on the phase diagram where all these states touch. This intersection of the three states is at 32.018 degrees Fahrenheit and 611.7 pascals. That's 0.6% of the pressure of the atmosphere on Earth, which is the same pressure of the atmosphere on Mars. Now, what is the triple point exactly? It's a point of equilibrium of a substance that allows it to be a solid, liquid, or gas. Small temperature or pressure changes in the system will change the contents completely to ice, liquid water, or water vapor. Today, I will cover how to use the triple pointed water cell. First, I will be going over the history of how the triple pointed water became a standard. Then, I will demonstrate how to use the triple point cell. Now let's cover a brief history of how this came to be. Eusebius, a Greek philosopher in the 5th century BC, proposed atavism, which defined how matter moved from state to state, meaning how it moved from solid ice to liquid water to gaseous vapor. John Gribbin, an astrophysicist and writer at the University of Sussex in 2003, stated in his book, Science, a History, 1543 to 2001, that the first person to really describe phase changes with anything similar to our modern understanding of what phase change really was a French chemist, Antoine Lavoisier, and that was done in 1778. James Thomson, an engineer and physicist, in his 1880 publication, A Collection of Papers in Physics and Engineering, was cited as the first person to define the triple point of any substance. Now, his younger brother, William Thomson, who was given the title Baron Kelvin in recognition for his achievements in thermodynamics, states in his journal of 1890 his new proposed scale of absolute temperatures with the units of Kelvin instead of Fahrenheit or Celsius, which used the triple point of water as the only reference point. Zuma Lee, who was a lead engineer at Cal Labs, covered in his 1995 publication, producing the highest level of accuracy from standard platinum resistance thermometers, the design and uncertainty calculations for the triple point of water cell that is now used by Fluke Calibration Bay, who is the main manufacturer of the triple point cell. Understanding how this science has evolved is great, but all we really need to know is that this is the most accurate calibration standard available for this temperature range. Now let's take a look at how to use the triple point of water cell. What you see here is water and water vapor. The water vapor is up here. Now, all the air was removed during the manufacturing process, so there's almost a complete vacuum in here. But there's still a slight amount of pressure. The ice mantle still needs to be formed around the center well, which will begin forming as the whole temperature of the water becomes a uniform 32.018 degrees. This is done by using an immersion freezer with a dry ice. This immersion freezer has a copper tube that goes straight down to this tip. By putting dry ice into the reservoir, it transmits the cold temperature down here. This is placed down in the well along with isopropyl alcohol and is allowed to cool off the water temperature. Now, as the ice mantle begins to form around the well, we will be looking for roughly a 1/4 inch thickness. And this will tell us that we have met the critical condition for the triple point ice mantle thickness. Once this is done, we'll have to break that mantle free of the well. A long rod would be heated by friction or using a little flame. And then it would be placed in this well to where it could radiate heat. This heat would go into the walls and allow for the heating of the ice mantle around the well. Now, once this is done, and there's a small amount of ice melted away from the mantle, a small twist would allow us to see the ice mantle rotate around the well. This would indicate that we now have a gap between the wall of the well and the ice mantle. Now this is important because if the ice mantle was freshly or completely against the well, then we would be measuring the ice temperature instead of the triple point temperature. With a small gap and water allowed to go into that space between, we're able to measure the true triple point water temperature. Once properly frozen, the ice layer will last about 8 hours, depending on how long or how well the insulation is for the containment unit. In some extreme conditions, it will last nearly 6 weeks, but this is using a maintenance bath that recirculates cool water, is constantly cooled with a very thick amount of insulations on either side. With a properly prepared triple point cell, the temperature probes can now be calibrated. Now that we have covered so much so quickly, let's refresh what that was. First, we covered the historical events that led to the discovery and use of the triple point system. Finally, I demonstrated on how to use the triple point of water cell. With this newfound knowledge, you will better understand the process that has gone through when attempting to measure the true temperature of anything.